we're going to identify the horizontal and vertical asymptotes of the following function. Just like we did with identifying the wholes, we're going to start by always factoring the numerator and the denominator. So in the numerator, I can see that all three terms contain an x. Let's take out one x, and I'm left with x squared plus x minus 12. If I distribute, I end up with exactly what you see in the numerator. Now I recognize that I can also factor this. 1 multiplies to give us negative 12 and combines to give us a positive 1 would be x plus 4 and x minus 3. Let's look at the denominator. Again, I can factor out an x. And what else can I factor out? I can also factor out a 4. And I'd be left with x squared minus 4x. And I need to get a positive, so let's try a positive 3. Now I need to make sure I did this right. This is 4x to the third, correct? This is negative 16x squared, correct? And positive 12x. Okay, that's looking good. So we have a 4x out front. And then are there two things that multiply to give us a positive 3 and combine to give us a negative 4? Yes, negative 3 and negative 1. Okay, so that's the first thing we're doing. We're going to factor it. Now let's start by talking about the horizontal asymptote. I'm going to be lazy and just put HA. Horizontal asymptote will always be written with the equation y equals. It's important for you to know that. Horizontal asymptote will always be y equals. It's going to cut through the y-axis at some value if it exists. How do we determine the horizontal asymptote? We're going to examine the degrees of the function. You're going to see me go through this more in example number 14. But if they have the exact same degree, then we're going to jump right in front of them to the leading coefficients and we're going to divide. So 1 divided by 4, in front of x to the third is 1, in front of x to the third is 4. So this is the equation of the horizontal asymptote for this function. Now, in order for us to figure out what the vertical asymptotes are, we're going to do the exact same thing that we did earlier in this task, not this particular question, but in task number 9, to identify the whole. So once it's in factored form, let's go ahead and let's see where the common factors are. So I think there is a common factor at x. We set it equal to 0. This is a potential whole. We're going to check in a little bit. Oop, here's another one. I think there is another potential whole at x minus 3. So I set each factor equal to 0 and I solve. So I add 3 to the opposite side. Remember, for your AP test, you do have to show all of this work. These are potential wholes. I need to go back and check in a little bit, and I'll show you how we're going to check. So I'm going to write down the simplified version, so x plus 4 over x minus 1. Now, if x equals 0 is a whole, we need to figure out what is the corresponding y value. So 0 and what value? 3 and what value? So we're going to take 0 and plug it in. 0 plus 4 is 4, 0 minus 1 is negative 1. So this would become, when I plug in 0, I get 0 plus 4 over 0 minus 1, 4 over negative 1, this would be negative 4. If I can find a y value, that means yes, there is in fact a whole. There's a whole here. Let's do 3. So I'm going to come over here where I have a little more space, and I do the simplified version, not the original function. So I'm plugging in a 3. So 3 plus 4 over 3 minus 1. So 7 over 2, which is 3.5 or 7/2. Again, I found a y value. So if they also said where are the holes in the graph, if there's a hole in the graph at x equals 0 and there's a hole in the graph at x equals 3. Remember, those holes also have a corresponding y value where they actually exist. These are the coordinates for the holes. We are also asked now, what is a vertical asymptote? So once I've determined the holes, I've already determined the horizontal asymptote because one that exists. Now I can look at this simplified fraction, and I'm going to take the denominator, and I'm going to set it equal to 0, and I'm going to solve. So this is the equation for the vertical asymptote. A vertical asymptote occurs at x equals 1.